So ideally, networking essentials or network basics is a unit or rather a topic that is going to help us understand the vital components of a computer network. So before you implement a network, you must actually understand this kind of network essential stuff that you're going to look at. So we looked at the definition of what a computer network is, and we agree that this is the interconnection of two or more computers, or what we refer to as nodes. Any connected device in a network is referred to a node. So it could be computers, it could be printers, right? So as long as there's some kind of interconnection of more than two devices in a network, that forms actually a network. So also you need to understand that this interconnection happens via unguided media and guided media, what we refer to as cables and wireless technologies, right? So there are many other devices that can be connected in a network, and we are going to have a look at these devices as we proceed, right? Ideally, also you need to understand why do we need a network, right? So we also looked at the various benefits and advantages. I think we mentioned one or two, but it's important also to maybe remind ourselves, right? So transmission of data cannot happen without a network. Right now, we are using emails, for example, right? So we can share messages, can share information, right? Our networks also can be configured in a way to help us securely communicate or share resources. So it prevents unauthorized access to our computers. We are going to look at network security later on and maybe understand how advantage it is. Remember also these advantages, if are not properly implemented, they can be seen as disadvantage. Like if we don't properly secure a network, it could be a disadvantage, right? We can also have a centralized way of actually taking care of our resources. So we are going to look at the different types of networks. We have peer-to-peer network. We also have client-server networks that will enable us understand the architecture, or rather the structures of this particular network. We can also be able to connect expensive devices, and these particular devices can be shared across the network. A good example is having a printer, right? So if you have a printer and you want people to access that particular printer, there's no need of purchasing for everyone that given printer. So you just need to purchase one printer and connect multiple users, right? So I think as we proceed, we are going to look at more advantages. But as I'd mentioned, also there are disadvantages of computer networks. One, they are very expensive to implement, right? To have a successful computer network, you need to purchase sophisticated hardware and software. So it also requires configuration. So you need to have personnel who are well conversant with implementing these particular networks. We also have mentioned about the security of the network. If they are not properly implemented, people can take advantage of our network so that they can transmit malicious codes or other malicious softwares such as viruses and so on, right? So we need to ensure that, in fact, the loophole that we have within a network is whereby people will use our network for malicious purposes. So if they find that we have particular hardware that has some design flaws or softwares that have some design flaws, they can always take advantage, right, and hack our systems, which actually is not a good thing. Since you have said that a network comprises of different architectures, and we are going to be looking at the client-server architecture, you realize that in a network, we normally organize or control functions in a centralized manner. So in such a case, if we have a centralized device such as a server, and then let's say it happens that the server fails, then our whole network is not going to operate. So we need to really factor in all these issues and any other disadvantage that you might think of. So there are some factors that also you need to put into consideration before you implement a particular computer network, or rather before or when you're evaluating the network. For example, you need to know what kind of traffic is your network carrying. Is it a voice traffic? Is it other related kind of traffic? Right? So what is the throughput? Is your network going to handle? Is the bandwidth, for example, are going to handle that kind of communication? Because if you are a network that shares a lot of files, then you have to look at the throughput keenly, and of course the cost. So before implementing a network, you need to budget, know the hardwares, know the softwares that are going to be purchased and implemented there. We also need to look at reliability. Not all networks are for general purposes. We have networks that really carry sensitive information, or rather perform very sensitive tasks. Like for example, if you are doing some kind of online surgery to a patient, or monitoring or diagnosing some machine using a particular network, it should be very, very stable. Yeah. So if there are kind of instability or unreliability to this particular network, chances are something might go wrong. Security wise, also we need to implement various security measures as you're going to look at. And we need to also have proper documentation. Documentation is going to help us when setting up the network for the very first time, when you are reviewing the network, and better still, when you want to upgrade this particular network, right? So if you want to define the proper policies and procedures for the organization, you need to have proper documentation. Other factor is flexibility. I've not mentioned also scalability. All these are some of the factors that we need to evaluate. Flexibility, we should be able to adjust our network by bringing on board maybe new hardwares, new softwares. If the network is becoming or growing bigger, we should be able to, it should be able to accommodate new users, right? So those are some of the factors that we need to put into consideration. I've not even mentioned about the architecture. Are you going to implement, for example, a peer-to-peer network, or are you going to implement a client-server network? We also need to understand the various types of computer networks. A network, as we have mentioned, is formed when two or more devices are connected. So as you connect multiple devices, that means the size of the network grows. So we can always associate a particular network based on its functionality and based on some set of criteria that we are just going to look at right now, like the speed of that particular network, right? So one of the mostly used network is the local area network. So a LAN, based on size, it's a very small network. You can implement it in a very small area such as home or office, right? You can also use wired and wireless cables. The good thing with the local area network is that it offers high data transfer rate. Yeah, the speed of the LAN is very, very fast. And of course, it's cheaper to implement. The problem is that since it covers a small area, then it limits you when you want to connect to a wide area. And that's why we need to understand the other type of network, wide area network. So wide area network comprises of multiple networks connected together. So in a wide area network, we have different devices, as you're going to look at. For example, let me just take you back to a local area network. You just need a simple device such as a switch, right, and a hub, and connect the computers. But in a wide area network, you have to purchase very expensive equipment and devices. You need to factor in the servers, right? You need to factor in the routers or the routers, right? And you need to factor also the transmission medium, because this wide area network covers a very wide area. So you need to have, if it is satellite dishes, you need to implement them. If you're using fiber optic cable, which is very expensive, right? So wide area network, as the name suggests, is a very, very broad kind of network, and to implement it, it's very costly. So ideally, it is very, very expensive. As I'd mentioned, you need to use some kind of satellite dishes. So that means the mode of communication or media here is normally through wireless technologies. We also talk about metropolitan area network. Metropolitan area network is actually a network that is slightly larger than a LAN, but smaller than a what? A WAN. So it is in between a LAN and a WAN. An area such as a city, right? Let's say Nairobi City, we can implement a metropolitan area network. In fact, the name speaks for itself, metropolitan, right? So it covers an area beyond 100 kilometers, but we are going to look at the specifics, right? So this is another type of network. We also have the storage area network. Storage area network is normally implemented for specific purpose or rather functionality. It is kind of a private network in that it stores or performs some kind of backup storage for organizations. So if you want to hire or lease some hardware and software for organization to store their data, then you could be using a storage area network. It is completely cut out from the main networks because of security issues. You see, when you store people's data, you need to be very, very, you need to isolate this particular network, right? So since it handles a lot of data transfer, then it has to be implemented using high-speed media such as fiber optic cables. We also have the other type of network, which is personal area network. As the name suggests, this is a network that allows you to share information at a very close range, like Bluetooth. Yeah, when you share information using Bluetooth, that one means you're using a personal area network. Ideally, if you want to understand a personal area network, communication happens within the vicinity of the sending and receiving device. So they have to be within a close proximity for them to be able to communicate. Like if you are connecting two devices, they should be within one room and not very, very far from each other. If you're using Bluetooth, the person who is sending and receiving should be also very, very close to the other person. We also have, I think, the list is quite long. I'll share the notes. We also have the home area network, which is almost close to the personal area network, but it is implemented at home. So if you have a network that is operating or carrying out some operations at home, then that is a home area network. Within the university, normally you are told to log into the university's Wi-Fi. Network whereby you can access resources within an institution, for example, We refer to that as campus area network, right? We also have the global area network, which also is a bit wide. Actually, they are almost similar to the wide area network. It's only that now it is kind of private. Like, for example, what Google Earth uses, right? What NASA, those people go to the moon, those kind of networks, right? So they can communicate within a private or controlled network. So those are global area networks. So in summary, there are comparison factors here that we need to take a look at. So we have just narrowed down to the three main networks, that is LAN, MAN, and WAN. We can have set of criteria to compare them, like the range, the distance, right? So you can see the LAN here covers a range of 1 to 10 kilometers, whereas the MAN covers almost 100 kilometers. WAN covers distance greater than 100 kilometers. You can also look at the media used, right? LAN mostly use cables and guided media, whereas from MAN to WAN they use wireless, or what we refer to as unguided media. The speed of LAN, as you can see, is quite very fast compared to the others. The cost of LAN is also cheap. Then we talk about the devices that are implemented within these categories of a network. So you realize that within a local area network, you will normally use a network interface card. You're going to see these devices later on, a switch and a hub. And as you advance the connection, you'll need the satellite dishes that provide the satellite waves, radio waves, microwaves, and so on. We're also going to look at network protocols. So the protocols we implement within a local area network are far different from the protocols that you implement within a wide area network. Like, for example, in a local area network, you'll implement some topology such as token ring. So you'll require token ring protocol or Ethernet, right? In a wide area network, you'll have to configure fiber distributed data interfaces and so on, the RAP and so on. So we are going to look at all these network protocols, and of course the applications that are used across these particular networks are also different, right? So that is ideally the different types of networks, but as I'd mentioned, this is just introduction. We are still going to look at them in details as time goes by. Then also we need to look at topology. When we talk about a topology, this is a layout, how you implement a particular structure. So in a network topology, we can always say you have logical topology and we have physical topology. Ideally, how you arrange the devices. You see, when you get into an office, you'll see how the computers are arranged. That is a physical topology. But when you configure these particular computers to share data, then you have to factor in the logical topology. So it's about how these particular devices communicate within a particular network. So in any given network, you need to arrange, you need to have some kind of layout that is implemented so that you can talk about the different topologies. So these are the well-known topologies. Talk about the bus, ring, star. We also have hybrid. So ideally, these topologies, they have some given advantages and disadvantages. So ideally, these topologies that we have mentioned here, they are the main topologies. So let's look at the bus topology. Now, the name bus simply means a straight line or a straight cable. right? So normally when you are implementing a fiber optic or a backbone cable, have you ever seen across the buildings people are digging some trunks and placing the fiber optic? So that particular cable can be seen as a way of presenting a bus topology, right? So we also need to terminate the ends of this particular topology. So this is just a diagram showing how the bus topology looks like. So you can see there's a straight line. That is a cable, backbone cable. It could be fiber optic. And then at the ends of the cable, you need to do what? To terminate them. What is the importance of terminating these cables? One is that if multiple devices want to communicate, there's always a problem of ringing back of the signal. So they'll wonder, if one side is not terminated, they'll wonder who is communicating, because the line will be ever busy. So there won't be a chance for any communication from the different devices to happen. So that's the main disadvantage. The other disadvantage of bus is that when there's a cut on the cable, right? Let's say there's a cut between one building and the other. It's very, very hard to know. Yeah. Unless there are some devices that you can use to pinpoint exactly where the cut of the cable is, right? So I think those are the main disadvantages, and of course advantage is that it is easy to implement. Not really easy, but it's expensive in a way that it depends with the cable that you're using. But it's easy because everything falls or otherwise just connects to a single cable. So there's no really hard job in connecting them in a single cable. Apart from the topology of bus, we have the star. As the name suggests, connection of these particular devices happen in a star manner, right? Normally, there's a centralized device, as you can see how the connection happens. One disadvantage, and that's what you have mentioned, is that if this centralized device fails or malfunctions, chances are every computer is not going to communicate, or rather send data. That's one disadvantage. In fact, it's a very major disadvantage. So it normally happens within the client server architecture. So this is a problem that this particular star topology has. Ideally, it has added advantages. One, when you have a centralized system, that means you can be able to easily manage the different devices. From that also you can get another advantage of security. So the centralized device can be able to monitor and determine which device is maybe not part of the network or rogue device, or we can also talk about filtering. Yeah, we can implement some firewall within this centralized device, so that when a bad traffic is coming from one computer, we can stop it from going to the next computer, right? So that's the importance of a star topology. We also have the ring. Now, ring topology, as the name suggests, computers are connected in a ring structure. We have talked about the token ring. Here, communication happens through the token, right? So, advantage of this is that it reduces the electromagnetic interference. When you have a ring topology, there's some kind of secondary ring and primary ring, right? This adds to the cost because you have to have the backup, right? So you have to implement both the main ring and the the backup ring, which is secondary ring, right? So the advantages here, unlike the star topology and the bus topology, advantage of this is that it reduces, as I'd mentioned, it reduces the collisions. Here, a computer can only be able to communicate once it has a token, right? You know how the relay race happens. So you are given that button is when you start running. So that's what happens. So a given computer must have the what? The token for it to be able to communicate. So you can see it actually isolates or remove these bouncing of signals and all these. We have talked about the EMI, right? So you have seen the disadvantage. I don't know whether you have another. So normally we have two set of rings in any given ring topology for backup purposes, but it is going to be costly if we implement the two, right? Mesh topology is another one. This particular topology is very, of course, it's very hard to implement. It's also expensive. Why? It has very many cables connecting multiple devices. Though the disadvantage, or rather the advantage of connecting every node or every computer, is that it increases fault tolerance, right? So that if one computer fails, there are other routes that the computers can use. Ideally, it enhances redundancy, right? So we can always use different routes, so we can't really have issues. But ideally, if you say this kind of topology, it uses a lot of connection points, so that makes it very, very expensive. We also have hybrid topology. The term hybrid simply means connecting two or more topologies. Like you can connect a given bus topology and a star topology, or you can connect a star topology with a ring topology, right? So you can do this as shown. So you can see we have bus topology here. We also have ring topology. They form a hybrid topology. So most networks implement a hybrid topology, because you can see one office can have bus topology, the other one can have ring topology. The one on the left is the tree topology, which you haven't looked at, but here it is. So tree topology, as the name suggests, it kind of connects devices in a form of branches, right? So it supports a lot of expansion, and as you can see, it also acts as a hybrid topology in that you can have a backbone cable connecting to a star topology. Someone might ask, what are the advantages and disadvantages? Very, very simple. You have to bring on board the advantage of star topology and bus topology, and also you have to bring disadvantages of bus and star topology to understand the pros and cons of a tree topology. So those are some of the topologies that you need to understand, because topologies are very, very important in a network. It's how you can always implement the structure of a network. Otherwise, if you don't understand the topologies, even to implement a network could be a problem. So let's look at the main thing here that allows us to have the networks: data communication, isn't it? So networks are formed to ensure that we can be able to have data being communicated either locally or from a remote location. But for communication to happen within a network, we need to look at some fundamental characteristics. One is the delivery time, right? So we need to ensure that, when you are composing an email, when you click on send, it does that very, very fast. And that's what is required. And delivery is actually enhanced when you have the right protocols. So we are going to talk about the various protocols that assist in data delivery, right? Because when you're transmitting data across the network, you need to have reliable protocols, for example, that will guarantee you that the data that moves from point A actually reaches point B. When you're delivering data, for example, we don't need just to deliver it. It should be accurate, right? If the data had 10 frames when it was being sent, we expect that particular data, or the recipient of that particular data, to also receive 10 frames. So the accuracy of this is very, very important. And I've said timeliness is also very, very important. How long it takes matters. Also, we need to look at what comprises of a data communication system. What are you going to send? You need a message, isn't it? Who is going to send this? We need to have a sender. So sender is the sending device. It could be a computer, right? It could be a router. The receiver is the receiving device, right? Medium, is it wireless or is it wired? Is it unguided? Is it guided? And how are we going to ensure that proper communication happens? We need a protocol. So protocol is a well-defined framework of how devices communicate within a network. When communication happens between two devices, we also need to factor in the communication modes, right? Like initially, when maybe we didn't have smartphones, we had the walkie-talkies. We had very funny ways of communicating. So there are three types of modes that you can use: simplex mode, half duplex, full duplex. What are they? Simplex mode is a backward way of communicating, but though there are devices that still implement it, right? Like use of, ideally there's no immediate feedback in a simplex mode, right? Like if someone is using television to broadcast, they can always just broadcast, but there's no feedback at that particular moment, right? So data can be sent only in one direction. I hope you get that. Half duplex, a bit improved. Yes, we have now back and forth communication, but it happens very, very slowly. Yes, so communication can happen, but not at the same time. Like the walkie-talkie that I've mentioned, you hear the cops normally talk over the walkie-talkie. Someone talks, then say over, is when the other person takes over and replies. We also have the full duplex mode. Is a bidirectional. This is a full implemented way of communication. So communication happens simultaneously, right? As you can see. So we have two set of lines that can help the sending and receiving devices to communicate. Now, when this particular communication happens, they happen through a series of bits in a parallel mode. So when we talk about parallel mode here, it comprises of multiple bits, right? It's like sending 5 vehicles, or rather 5 vehicles using one highway or one route, rather than one vehicle using that route at the same time. So serial simply means one at a time. Parallel means many at a time, right? So normally when you have a setup of a cable, they normally take up 8 wires. So if you utilize the entire 8 wires to send the 8 bits, we say you're using a parallel mode. It's fast but very expensive. Then you have the serial mode. Serial mode is where one bit is being released at a time. It's a slow way of communicating anyway, right? Normally implemented within asynchronous systems and synchronous systems. Asynchronous is where it's not real time, yeah. You can maybe send and then wait for feedback later on. As synchronous, it happens in a live manner. So like if we do a face-to-face communication, then we can say there's a synchronous communication. We are going to look at network components in details. Ideally, right now, you need to factor in the two major components, hardware and software. So if you want to implement a network, you need to have the proper hardwares and the proper softwares. So examples of these hardwares could include the server, right? We're going to look at what servers are in details and examples of these servers. We also have client. Client computers are the ones that the users normally use. So if you want to connect to a network, use the client computers. Media, these are the cables. We're also going to look at the various cables, and of course the network interface card. This is a connection point where you connect your cable to the computer. Better still, you need to have the software, the operating systems. We normally refer to them as network operating system, right? And the client operating system. So when we talk about local operating system, that simply means the client operating system. Whatever your computer is using, that is the client operating system. Whatever the server is using, it uses the network operating system. And we are also going to understand the OSI framework or model and the TCP model. We refer to them as reference models. They are the ones that assist us to understand how these particular components are implemented. Now we have the software that runs on the server and the software that runs on the client. I've already mentioned that. So those are the two sets of softwares that you can always have. Again, we have talked about the structure of the network. These are the layout, or rather how you implement a particular network. So we have looked at the physical and the logical topologies, but it's important to understand how then does this particular computers communicate. So we have peer-to-peer networks and client-server networks. So you'll realize that some organizations, they implement both the networks, but ideally in most organizations they normally implement the client-server architecture. What I can say is this: peer-to-peer networks normally are implemented on top of a client-server architecture, mostly, right? So wherever you see a peer-to-peer network, chances are at some point they could use a client-server architecture, but they are different, as you're going to see. So in a client server, the server is a centralized computer. Actually, what is a server? A server is a dedicated computer within a network that performs the work of responding to requests from a client computer. So as you can see here, we have a file server. So if you want to download a particular file, or rather upload it, you need to contact the file server. So the server is the one that is going to respond. Otherwise, you will get the server is down kind of error messages. So that's how client server network is. So one computer plays the role of a server. It responds to the requests. As we say, it offers better security in that only one centralized system has the right to respond to the requests. It also supports many users, so you can connect multiple users, right? Then we have the other one, peer-to-peer architecture. So as you can see here, the peer-to-peer architecture, all communicating devices are equal. I normally talk about students in a class, so your peers, yeah. So anyone can be I mean, you can play two roles at the same time. You can either be a client or you can decide to be a server. So no one is going to tell you that unless if there's a class rep who can play the role of a server, right? Who can tell you to keep quiet. But ideally, peer-to-peer networks, all the communicating devices are equal. There are pros and cons of this kind of architecture. One, in a peer-to-peer network, since all devices have equal rights, chances are there could be an issue with the management of resources, right? There are some devices which can decide to victimize other nodes or other connected devices, right? Like there's one which can decide it is the one that is communicating all through. Security wise, since every connected device has an equal right, then managing security is very, very difficult. They can download, install softwares as they wish. Also, every communicating device can randomly communicate. That means there'll be a lot of collision within a peer-to-peer network. So we're going to look at maybe how to avoid these collision, how to detect them, and so on, right? So in a peer-to-peer, there's no server. So as you can see, they are generally small in size. They are also cheap to implement compared to the client server architecture. The security is poor, and so on and so forth. So as you have mentioned, this is how the peer-to-peer looks like. So you can see every computer here is equal, so no problem. Then we can also look at the transmission media, right? Transmission media, now we need to understand how we can transfer data from one point to the other. So we have the guided medias, and of course you have also the unguided media. Guided media simply means using cables, right? And we are going to look at the different types of cables, such as twisted pair cable. I know you guys are familiar with these. A coaxial cable. We also have a fiber optic cable, right? So these are normally implemented within a local area network and partially a metropolitan area network. For unguided media, you can also implement them partially within a local area network, but majority of the devices or implementation of unguided media happens within a wide area network. Talk about radio waves, microwaves, and so on. So wired media constitutes the twisted pair cable. Let's look at them. We also have coaxial cable, fiber optic. Now twisted, as the name suggests, normally a twisted cable. Let me just go to this next. Yeah, this is how it looks like. A twisted pair cable, as you can see, they are normally twisted. They actually comprises of 8. You remember the 8 wires that transmit 8 bits, right? So we have set of wires that are color coded. These particular wires, they specifically transmit some given data. It's not that they're just like that. They are always coded so that they can be able to transmit some kind of data. And you can see, why are they twisted? That twisting enables the eradication of what we refer to as the crosstalk. Crosstalk means that if these particular cables are not twisted, there will be kind of interference of the data being transmitted, right? We talk about electromagnetic interference. Let's go back now to this. So as you can see, they still have issues of interference, even if they are twisted. They're cheap. You can always purchase these very, very cheaply, right? Then the connectors of these, Don't know why I didn't capture this. Now at the end of this cable, normally there's some jack. The registered jack 45 connector is normally placed at the end of this particular twisted pair cable. For the That is for the 4 pairs of wires, and then you have the 2 pairs normally connecting the telephone lines, right? So they are a bit smaller. So for this it is RJ45. For the smaller one it's RJ11. They're normally RJ11 connector, so don't get confused. Let's look at the other one, coaxial cable. It has been here for a while actually. Normally use it at home, right? So the connector that is used here is British naval connector. It's actually this one. As you can see, the coaxial cable, it has some kind of sheath or shield. Someone might ask you why. You all know. So to reduce the crosstalk, it also reduces the electromagnetic interference, right? So you can see the main conductor has actually a lot of protection, because that is what is actually transmitting the signals. Then you have the outer jacket. So it's actually properly clothed. Yeah, it's properly clothed with this particular shield. We have foil shield. Every layer or shield performs additional or gives an additional protection layer to avoid this particular noise, interference, and so on, right? We also have fiber optic cable. When it comes to data transmission, we normally prefer fiber optic cable because it's actually not susceptible to electromagnetic interference. Again, also it is more secure. It's not very easy to tap into the data that is being transmitted using fiber optic. You see, there are people who can always plant some devices around these other cables to tap and to get to redirect the traffic, but for the fiber optic it's very, very hard. Though fiber optic, though it's good, but it's very expensive, right? And very difficult to install, right? So they use some set of glasses, and someone says, actually not someone, it's actually, they're very poisonous, those glasses. So when you get across a fiber optic cable, you need to handle it with a lot of care. Those are cables, right? Those are cable. Then we have wireless or unguided media. So unguided media, here we talk about the wireless media, right? So we can talk about infrared communication. We can also talk about the broadcast radio, satellite communication. We also have Wi-Fi. All these are wireless. I know you are familiar with Bluetooth, right? Wi-Fi. Now, ladies and gentlemen, that's actually how, or the network essentials components look like. So we can say we have just introduced the various networks, the various topologies, the various softwares. So going forward, we need to understand in details how these particular components can be integrated together to form a given network. So we can summarize our today's lesson by looking at this particular diagram. So this diagram constitutes everything that you've already learned. I can see wireless form of communication, top left, where the laptops are, you can see. And the device that is offering these wireless signals is the Wi-Fi router, you can see. Then you can see those lines. Those ones are the wired cables. It could be they're using fiber optic. Who knows? It could be that they're using the twisted pair cables, right? The high chances that they're twisted pair cable, right? I can also see the server. So this one confirms that it's a client server architecture that has been implemented here from what we have discussed, right? So server here responds to the various requests from the connected devices. I can also see bottom left, the ring topology has been implemented here. So you can see various computers passing tokens using the ring topology. I can also see the star topology, and generally I can see a hybrid topology. I can also see the various devices, though we haven't talked about them. We are going to mention them because you need to know exactly what a router is. What are the functions? What are the features of a router? How do you differentiate between a router and a switch? Right? So that's what you're going to look at later on. Ideally, you can see the one function of the router is to connect you to the internet. That's why it's pointing to the internet, and it's the only device that is pointing to the internet. Then we have switch that is extending the networks, right? So ideally, that is why we need to have a network in place. So you are somewhere there, you're using this network to participate in the virtual class, right? So if something happens, if we have issues within the network, then we can't be able to communicate. So we are going to look at all those factors. So allow me to stop there unless there's some question.